Hello Algebra 2 students, this is a video for example 1 for section 1.4 arithmetic sequences and series. The essential question, what is an arithmetic sequence and how do you represent and find its terms and their sums? A lot of vocab in this section. Arithmetic sequence, arithmetic series, common difference, explicit definition, recursive definition, sequence, series, sigma notation. And in the end, you'll be able to interpret arithmetic sequences and series. Let's go ahead to example 1. Understanding arithmetic sequences. Is the sequence arithmetic? If so, what is the common difference? What is the next term in the sequence? So we see it's going up. We have the first term is a 3, second term is an 8, third term is 13, fourth term is 18, fifth term is 23. So those term numbers are natural numbers. It just always starts off with 1, 2, 3, 4, 5, and up. The term are those numbers there, 3, 8, 13, 18, 23. And the next thing we look for is it going up by the same amount or is it going down by the same amount every time? And it is. It's going up by 5. 5 plus 5 plus 5 plus 5. An arithmetic sequence is a sequence with a constant difference between the consecutive terms. This difference is known as the common difference. So plus 5, positive 5 is the common difference. Since we know it's going up by 5 every time, we can find the next term by just adding 5 to the last term that we knew about, 23. 23 plus 5 is 28. That's how simple it is to see if it's an arithmetic sequence, and if it is, how to get the next term. Now we want to practice writing a formula, which is a little more confusing. How could you write a formula for finding the next term in the sequence? First, each term can be represented by f of n, where n represents the number of the term, like the fourth term would be, or f of 4 would be the 18. So we have a starting point. When n equals 1, the first term is 3. And then for any term after that, we just want to add 5 to the previous term, so we can write it like this. F of 2 equals f of 1 plus 5. F of 3 equals f of 2 plus 5. So in general, f of n is going to equal f of n minus 1. That's the previous term. For example, if n were 17, this would be the 17th term, and then 17 minus 1 would be 16. This would be the 16th term. And what do we do to the previous term? We're going to add 5. That's one way of writing it. In general, it would be written like this piecewise function here. It's a recursive definition for an arithmetic sequence. More commonly, though, you will see this. A subscript n has two values. It equals a subscript 1 for the first term, and then since everything builds off the first term, we take the previous term and we add the common difference, or we would subtract. If the common difference were a negative number, it'd essentially be subtracting every time. So that's what we're going to look for when we write a recursive definition. I think on the next screen, let's take a look. Is 4, 7, 10, 13, 16, and so on arithmetic? If so, write the recursive definition for the sequence. We have the first term is 4, and it is going up by the same amount every time. It's going up by 3, so we have a common difference is 3. So it is an arithmetic sequence. It's going up by 3 every time. How to write that? We have the first term is 4, and then every term after that, we have to add 3 to it. That's how you can write it. Okay? I'll show you another way of how to write it with my answer to this problem here. These are the trial ones, so you're going to try them on your own. First, let me read the question. Are the following sequences arithmetic? If so, what is the recursive definition? And what is the next term of the sequence? We have 20, 20, 25, 20, 15, and 10, and so on and so forth. And we also have 2, 4, 7, 12, 13. So think about those, click pause, come back when you're ready. All right, for the 25, 20, 15, I notice it's going down by 5 every time. I didn't write the next term, but it's going down by 5 every time. So that means D is negative 5. So when I go to write my recursive definition, the first term is 25, and every term after that builds off of that. It builds off the previous term. We're going to take the previous term, and this time we're going to subtract 5 from it. A recursive definition will always have these parts. It'll always have a1 equals something, and a subscript n equals a subscript n minus 1. So all you have to do is figure out what to put in here and what to put in here. And notice it's pretty straightforward. This is the first term, and this is the common difference. Okay, and the second one, if you haven't had a chance to think about that, click pause, come back. Right off the bat, I see it goes up by 2, and then by 3, and then by 5. It's not going up by the same amount every time. So it's not even an arithmetic sequence. So you don't have to do any more work, because that's the first question. Is it an arithmetic sequence? For homework, your teacher might assign some of these problems. 18 through 21, 36, and 13. That's it for this video. Have a great day.